Hi, we are going to discuss hypothesis testing and non-parametric tests. I am RK. We will discuss about the types of data first and the examples. So nominal data and ordinal data. Nominal data is used only for references. We can't do anything analysis and things like that we can't do. Ordinal data or ranked data. Number of passes, pass, fail is the ordinal data. Blue, black are all nominal data. And pass 68 people, fail 30 people, withheld 2 people. And how do we use this? We will see later. And interval and ratio data are continuous data. Marks scored are interval data. Kg, weight and things are all ratio. Height, weight and all ratio data. Temperature, zero temperature means there is a temperature there. There is a hot heat, a measure of heat, and heat is there even at 0 degrees. And minus 23 also, minus 230 also is there. Therefore, 0 is not actually 0. Absolute 0 is accounted in weight and height. Because when there is no height, it is 0. But when there is temperature is 0, that means there is a temperature. Therefore, these are called interval data, these are called ratio data. So, this is nominal data and continuous data is given there. So, we are going to see how we are going to analyze this data. Similarly, nominal data and ordinal data are there. So, is there a possibility to analyze this type of data? We will see this. Types of data and the possible reports. Nominal and ordinal data we are using for reporting in the form of pie chart, bar chart and radar chart. Interval and ratio we are using distribution charts, normal distribution, another type of distributions, any uniform distributions, exponential distributions, Weibull distributions and things like that, and we can do an analysis of the data. But ordinal and interval and ratio data, can we do anything? Because here we say ordinal data we can't do analysis, but is it possible to do an analysis with ordinal data or interval data? Yes, it is possible. That is what we are going to see. So, pass, fail, withheld. Number of pass, number of fail and number of withheld is there. How do we report this? So, we can report it as a pie chart. You can see here 30, 68 and then 2. Or we can give it as a bar chart. So, 68, 30 and 2. Or we can give it as a radar chart. So, we will see about radar chart later on, because radar chart also is mostly used there. We are splitting into 3 parts: pass, fail and withheld. From the 0, how far is it? We are marking it and then drawing a line. What is a parameter? Option 1, a numerical quantity. Option 2, characteristic of a given population. Option 3, an aspect of population. Option 4, all the above. The correct answer is option 4, all the above. Select the most common statistics parameters. Option 1, mean and standard deviation. Option 2, mean, median and mode. Option 3, both the above. Option 4, none of the above. The correct answer is option 3, both the above. Student t-test is an example of option 1, parametric test. Option 2, non-parametric test. Option 3, both the above. Option 4, none of the above. The correct answer is option 1, parametric test. Select the correct statement. Parametric tests involve data in absolute values rather than ranks. Option 2, restricted to data on the same continuous scale of measure. Option 3, both the above. Option 4, none of the above. The correct answer is option 3, both the above. Select the correct statement. Parametric tests have their data follow a normal distribution. Option 2, independent of one another. Option 3, both the above. Option 4, none of the above. The correct answer is option 3, both the above. In a parametric test, validity of the assumption decides the dependency of the results. Option 1, true. Option 2, false. Option 3, both the above. Option 4, none of the above. The correct answer is option 1, true. In a parametric test, we test the significance of the computed sample statistics. Option 1, true. Option 2, false. Option 3, both the above. Option 4, none of the above. The correct answer is option 1, true. Select the correct statement. Option 1, parametric tests assume population parameters from which data are drawn. Option 2, non-parametric tests make no assumption about the population parameters from which the data are drawn. Option 3, non-parametric tests are called distribution-free tests. Option 4, all the above. The correct answer is option 4, all the above. Both parametric and non-parametric tests are option 1, used to make inferences about various population values. Option 2, used to find the sample behavior under specific conditions. Option 3, both the above. Option 4, none of the above. The correct answer is used to make inferences about various population values. Select the correct statement. Option 1, non-parametric test is based on ranks of observation. Option 2, non-parametric tests do not depend on any distribution of population. Option 3, non-parametric tests do not assume any fixed structure of your model. Option 4, all the above. The correct answer is option 4, all the above, because all the three statements are true. Select the correct statement. Option 1, if population information is known by its parameters, then the statistical test is parametric test. Option 2, if population information is not known but still required to test the hypothesis, then the statistical test is non-parametric test. Option 3, both the above. Option 4, none of the above. The correct answer is option 3, both the above. Select the correct statement. Option 1, null hypothesis is free from parameters in non-parametric test. Option 2, non-parametric tests are applicable for both variables and attributes. Option 3, parametric tests are applicable only for variable. Option 4, all the above. The correct answer is option 4, all the above. Select the correct statement. Option 1, no parametric tests are there for nominal scale data. Option 2, non-parametric tests exist for nominal and ordinal data. Option 3, both the above. Option 4, none of the above. The correct answer is option 3, both the above. Which test you will use to test the significance of mean length or height? Option 1, parametric test. Option 2, non-parametric test. Option 3, both the above. Option 4, none of the above. The correct answer is option 1, parametric test. Which test you will use to test whether bacteria grow or not in the population? Option 1, parametric test. Option 2, non-parametric test. Option 3, both the above. Option 4, none of the above. The correct answer is option 2, non-parametric test. What are the advantages of non-parametric tests? Option 1, simple and easy to understand. Option 2, no complicated theory involved. Option 3, no assumption about population. Option 4, all the above. The correct answer is option 4, all the above. Is chi-square test a non-parametric test? Option 1, yes. Option 2, no. Option 3, none of the above. Option 4, all the above. The correct answer is option 1, yes. Chi-square test has no assumptions about the distribution. Therefore, it is a non-parametric test, but has assumption on expected values and independence of data, that is immaterial. What test used to test the difference between two independent groups with ordinal or continuous dependent variable? Option 1, Mann-Whitney U test. Option 2, Wilcoxon sign rank test. Option 3, Kruskal-Wallis test. Option 4, Spearman rank correlation test. The correct answer is option 1, Mann-Whitney U test. What test you use to test the difference between two related variables taking into account the direction of difference? Option 1, Mann-Whitney U test. Option 2, Wilcoxon sign rank test. Option 3, Kruskal-Wallis test. Option 4, Spearman rank correlation test. The correct answer is option 2, Wilcoxon sign rank test. What test you use to test to compare the outcome among more than two independent groups using medians? Option 1, Mann-Whitney U test. Option 2, Wilcoxon sign rank test. Option 3, Kruskal-Wallis test. Option 4, Spearman rank correlation test. The correct answer is option 3, Kruskal-Wallis test. What test you use to test to check if there is a relationship between two data sets and get the relationship? Option 1, Mann-Whitney U test. Option 2, Wilcoxon sign rank test. Option 3, Kruskal-Wallis test. Option 4, Spearman rank correlation. The correct answer is option 4, Spearman rank correlation test. The procedure for non-parametric tests. Step 1, set up the hypothesis and opt a level of significance. That is, null hypothesis H0 is Rahul is going to win the race. Alternate hypothesis is what we want to prove. H1 is Rahul is not going to win the race. We set the alternative hypothesis equal to what we want to prove. Alpha is 0.05, that is significance level is 95%. Alpha is equal to 5%, that is 0.05. Step 2, set a test characteristic. Average marks of the students in section A, B, C and D. Please note total marks, not total marks. Average marks of A, B, C and D. So one value for each section we will get. So we are ranking A, B, C, D based on the average marks. The observed sample is converted into ranks and the ranks are treated as test statistics. That is, we are converting the marks to ranks and then using it as a test statistic. Step 3, set a decision rule. P-value or test value, test characteristic value. If p-value is less than 0.05, reject the null. If p-value is greater than or equal to 0.05, fail to reject the null. Step 4, calculate this test statistic. Use the ranks to compute the test statistic. Step 5, compare the test statistic to the decision rule and conclude. That is, make a conclusion. If test statistic is greater than or equal to critical, that is table value, that means p-value is less than 0.05, then reject the null. If test statistic is less than critical, that is table value, then p-value is greater than or equal to 0.05, so fail to reject the null. So that is what I am going to put now. If p-value is less than alpha value, reject the null. If p-value is greater than or equal to alpha value, fail to reject the null. What is alpha value? 0.05, which we are fixing it in the step 1. Now we will see an example. I am buying a t-shirt X size at Chennai for rupees 2,500. One of my friend SR is buying at Bombay, that is Mumbai, buying the same shirt at rupees 2,000. Now we want to know, does the region affect the price of a commodity? If so, is there a link? There is a link between region and price, right? The null hypothesis is there is no link between the region and the price of the shirt. Alternately, we can also say that null hypothesis is there is no link between the region and the price of vegetables or any commodities. Example, we will see Mann-Whitney U-test. A pharmaceutical organization created a new drug to cure sleepwalking and observed the result on a group of 5 patients after a month. Another group of 5 has been taking the old drug for a month. The organization then asked the individuals to record the number of sleepwalking cases in the previous month. The result is, so new drug users, first month 7 cases, second month 8 cases, third month 4 cases, fourth month 9 cases and fifth month 8 cases. Old drug users, first month 3 cases, second month 4 cases, third month 2 cases, fourth and fifth month 1 case each. The number of sleepwalking cases recorded in a month while taking new drug is higher compared to cases reported while taking older drug. That is what we see here. Mann-Whitney U-test or Wilcoxon rank sum test is an alternative to independent sample t-test. Right? For continuous data we use this, for rank variable we are using this Mann-Whitney U-test. Now, how are you comparing old drug performance, new drug performance? See, this is the new drug performance, this is the old drug performance. And in bar chart, new drug performance, old drug performance. You can see from the figure it is performing well because the scale here is only 4 here, the scale here is 8. Right? And radar chart, old drug performance, new drug performance. Right? You can see the value is 6 here, whereas the value is only 2 here. Right? We want to know whether the two groups taking different drugs report the same number of sleepwalking cases or not. Null hypothesis, the two groups report the same number of cases. Alternate hypothesis, the two groups report different number of cases. Level of significance, alpha is 0.05. Test statistic, U. We will see how to find out this U. This is the minimum of U1 and U2. We will find out U1 and U2 now. U1 is equal to N1 into N2 plus N1 into N1 plus 1 by 2 minus R1. We will see what is N1, N2 and R. Similarly, U2 is equal to N1 and N1 into N2 plus N2 into N2 plus 1 by 2 minus R2. So, where R1 is the sum of ranks of group 1, R2 is the sum of ranks of group 2. Right. N is the number of cases. Compute the ranks by combining the two groups. Sleepwalking cases, the data is there. I am going to combine this. So, old drug, new drug, I am putting it in the order 1, 1, 2, 3, 4, the same data. And then this one I am putting it in the ascending order 4, 7, 8, 8, 9. Please see here the first and second row having the same numbers. So I can't give rank 1 and rank 2 here. Therefore, I am splitting this into two parts. 1 plus 2 is 3, 3 divided by 2 is 1.5. Therefore, 1.5, 1.5 rank is given for the first two rows. So the third one is third row 2. old drag users cases is 2. This is the rank given 3 because 1 and 2 is already used, therefore rank 3 is used for this and rank 4 is used for this. And here again there is a tie, OD as well as ND, old drag users, new drag users, cases are same. Therefore I have to give 5 and 6. I am splitting into 5.5, 5.5. That is 5 plus 6 by 2 is 5.5. And then next row I am giving 7th rank because 5 and 6 are used. Next row and next row there is a tie. Therefore I am going to use 8 and 9, splitting into the 2 equally. So 8 plus 9 by 2, 8.5, 8.5. And the last one I am giving the rank 10. If you add this, you get 15.5. If you add for new drag, you get 39.5 as the summation of ranks. Now N1 is equal to 5 for the new drag, N2 is equal to 5 for the old drag users. Total is N is equal to 5 plus 5, 10. Sum of ranks is 55. That is what we see here. 15.5 plus 39.5 is 55. How do we get it? N into N plus 1 by 2. N is 10. Put N is equal to 10. 10 into 11 by 2 is 5 into 11, 55. So U1 we are getting by substituting the values. N1, N2 is 5 into 5. N1 into N1 plus 1 by 2 is 5 into 6 by 2. 5 into 3, 15. Minus R1 is 15.5. You get 24.5. Similarly, U2 we are getting for new drug users 0.5. Now U is the minimum of U1, U2. So minimum of 24.5 and 0.5 is 0.5. Now we are going to compare this U. U always lies between 0 and N1, N2. N1, N2 is 25. So we are getting 0.5. Therefore decision rule is if U is close to 0, then groups are completely different. If U is close to N1, N2, then there is some relation between the two groups. So U is equal to 0.5 close to 0. Therefore we are rejecting the null. The groups are completely different. Conclusion, there is no significant evidence to suggest that the two groups report the same number of sleepwalking cases. Example 2. Wilcoxon signed rank test. A teacher taught a new topic in the class and decided to conduct a surprise test on the next day. The marks out of 10 scored by 6 students are given here. So 6 students are there, 1 to 6. Marks scored by them are given here in the second row. Assume that this data violates the assumption of normal distribution. So we can't use the continuous data distribution applications. Therefore, the ranked variable we are using and non-parametric test we are going to use. Parametric test we cannot apply because it violates normal distribution. Now the teacher decides to conduct a test again after a week of self-practice. The scores or the new scores are given here after a week. And now check if the marks of the students have improved after a week of self-practice. That is whether this effort has improved the performance or not. Right? Wilcoxon rank test, critical W values, how we are going to compare I am giving. This is a table we have to refer, and for one side test 0.05, that is alpha value 0.05, one tail test, the value is 1, that is 5, number of data is 5, alpha is 0.05 one side and the W critical is 1 here. So this is what we are going to compare with and take a decision. So student 1 to 6, test 1, test 2 marks are given here. I am finding out the difference between the test marks, that is 6 minus 8 is minus 2, 8 minus 6 is plus 2. Similarly, I am finding it for all the students. Please note, students are nominal data. These are all marks. Now analyze if the difference is systematic or random due to chance by nature, or is it due to the effort that we have put in. Systematic means because of the effort that we put in. Assign the ranks to the absolute value of differences after arranging the data in ascending order. That means we are going to arrange this order. 1 will come first, the 2 and 2 will come next, and then 4, 7, 4 and 4 will come next, and then finally 7. So we have arranged the data in the ascending order 1, 2, 2, 4, 4, 7. And the rank is absolute we are taking 2.5, 2.5, 4.5, 4.5, 6. Please see here, I have changed the rank from 2 to 2.5 because there are 2 ranks. Therefore, this is split into second rank and third rank. So 2.5 is the rank. And 4 and 4 is split into 4 and 5. So 4.5, 4.5 I am splitting. Now I am bringing that sign back. So minus 1, 2.5, minus 2.5, 4.5, 4.5, 6. Now I am going to add all the negative values and all the positive values separately. Null hypothesis is the two groups report the same number of cases. Alternate hypothesis, the two groups report different number of cases. Level of significance, alpha is equal to 0.05. So consider one-sided hypothesis. The test statistics W is equal to minimum of W1 and W2. W1 is 3.5 because minus 1 plus minus 2.5 is minus 3.5. And then summation of plus values is 17.5. If you add this, 2.5 plus 9 is 11.5 plus 6 is 17.5. So W1 is equal to sum of the positive ranks, W2 is equal to sum of the negative ranks. Therefore, W1 is equal to 17.5, W2 is equal to 3.5. So W is the minimum of these two values, that is 3.5. Critical value from the table we have found out to be 1. W is greater than W critical, therefore accept the null. Conclusion, there is no significant difference between the marks of the two tests. Decision rule, if W is less than or equal to W critical, reject the null. If W is greater than W critical, accept the null. Right? Example 3, Kruskal-Wallis test we will see. Patients suffering from dengue were divided into 3 groups and 3 different types of treatments were given. The platelet count of the patients after following a 3-day course of treatment is given here. So treatment 1, treatment 2, treatment 3, the readings are also given here. The sizes are varying here. Now, N1 is equal to 5, N2 is equal to 3, and 3 is equal to 4. So that is what is it. Total size is 12. NS is 12. So H0 is null hypothesis, 3 population medians are same. H1 alternate hypothesis is 3 population medians are different. Kruskal-Wallis test is an alternative to ANOVA when data violates normal distribution and also when the sample size is small. Because we can rank them. Order the samples from smallest to largest and assign the ranks to the clubbed sample. We can also do it from largest to sample or smallest to largest. So treatment 1, treatment 2, treatment 3, I am clubbing them and ordering them here. See here 42,000, 45,000, 48,000, 57,000, and then I am leaving a gap here because 57,000 comes in treatment 2 and 67,000 is next, and then only comes 69,000 given under treatment 1. That is why we call it as a clubbing them and then putting them in the ascending order. And then comes 67,000 is tied between treatment 2 and treatment 3, and then comes 69,000 for treatment 1, then comes 78,000 for treatment 3, then comes 79,000, and 80,000 is shared by treatment 3. Therefore, we are going to give the rank accordingly. So 1, 2, 3 and 4 and 5, we can't give 4 and 5 here or here. Therefore, I give 4.5 to both. And similarly here 6 and 7 we can't give to any of this because we will be biased. Therefore, I am giving 6.5, 6.5, and then 6 and 7 are used. Therefore, 8, then 9, then 10, then 11, and then 12. So now I find out the summation of the R's, that is ranks. N into n plus 1 by 2 total summation is 78. We can check up here. 18.5 plus 38.5 is 57 plus 21 is 78. Right. So chi-square critical values for comparing and making a conclusion is given here. This is a chi-square curve. For chi-squared alpha value we are going to fix 0.05 and degree of freedom 2. Therefore, we get 5.991. So chi-squared for degree of freedom 2 and then alpha value 0.05 is 5.991 from this table. You can also get it from the Excel or any other software. Find the test statistic H based on ranks and reject the null if H is greater than or equal to H critical. Accept the null if H is less than H critical. So H is given by this formula 12 by n into n plus 1 sigma j is equal to 1 to k rj squared divided by nj minus 3 times n plus 1. So n is 12, we know 12 plus 1 13 into 3 is 39. That is what is this. This is 12 divided by 12 into 12 plus 1. We get this value 0.07692. And for the treatment 1 we get 68.45. For the treatment 2 we get 147. For the treatment 3 we get 370.57. So k is the number of comparison groups 3. N is the total sample size 12. Nj is the sample size in the jth group. N1 is 5, N2 is 3, N3 is 4. Rj is sum of the ranks in the jth group. For j is equal to 1, R1 is 18.5, R2 is equal to 21, R3 is equal to 38.5. That is what we were using in Rj squared by Nj. R1 squared by N1 is 18.5 squared by 5. Similarly, R2 squared by N2 is 21 squared by 3. And R3 squared by N3 is 38.5 squared by 4. And substituting, you get 6.0778. So the calculation gives you 6.08, and the critical value from the table is 5.991. We have seen it before. Therefore, 6.08 is greater than 5.9. Therefore, H is greater than or equal to H critical. P value is less than 0.05. Therefore, the decision is reject the null. So we will see where parametric test is used, where non-parametric test is used. Correlation test, independence measures, independent measures for more than 2 groups, that is K groups, and repeated measures, 2 groups, repeated measures more than 2 groups, K groups. So Pearson test we are using, and T test we are using for independent measures 2 groups, and independent measures for more than 2 groups ANOVA one way we are using, repeated measures for 2 groups paired T test, repeated measures for K groups we are using ANOVA with replication. Now for non-parametric test, for correlation test we are using Spearman test, independent measures we are using Mann-Whitney U test, independent measures more than 2 groups Kruskal-Wallis test, for repeated measures 2 groups Wilcoxon test, and repeated measures more than 2 groups Friedman's test. Example 3, Spearman rank correlation test. So this is the data, and the null hypothesis, there is no relation between the effect of new drug and the old drug. The number of cases are same. Alternate hypothesis, the number of cases are different. There is a relation between the effect of new drug and old drug. Spearman correlation, RS, is an element of closed interval -1 to 1. That is varying from -1 including -1 to +1 including +1, any number. If it is -1, a strong negative relation. If it is +1, strong, perfect, positive relation. If it is 0, there is no relation. RS is equal to -1 represents a negative correlation between the ranks. RS is equal to 0 means no correlation between the ranks. RS is equal to +1 represents a positive correlation between the ranks. That is what I said. Formula for Spearman rank correlation, when there are no ties in the data, I will tell you what do you mean by ties. The marks are same, the ranks are same, then that is called ties. The formula is RS is equal to 1 minus 6 times sigma di squared divided by n into n squared minus 1. When there are ties, now we will see how many ties are there, and then for each tie we are using. Suppose there are 2 ties here, tie 1 and tie 2 here, right? RS is equal to 1 minus 6 times, the denominator is same, n into n squared minus 1, numerator sigma di squared, plus for the first tie T1Q minus T1 divided by 12. For the second tie we are using T2Q minus T2 by 12, plus if there is one more tie we will use T3Q minus T3 divided by 12, right? So here is the marks, mathematics and science marks. We want to see whether there is a correlation. Null hypothesis, there is no relationship between the marks. It is not that if you score marks, you will score marks in maths, you will score more marks in science also. It is not like that. That is what we want to see. Alternative hypothesis H1 is there is a relationship between the marks. If you score maths high marks, science also will be scoring high marks. That is called monotonic relation. Alpha is 0.05, that is significance, level of significance. Now calculate the rank, that is the difference between the marks. Sample size n is equal to 10 because we are having 10 data. You know this is the visualization of the correlation coefficient. If it is 0, there is no correlation. If it is on this side towards -1, negative relation. If it is towards the positive 1, then it is a positive correlation. The marks are given in the row format. Maths 10 marks and science 10 marks are given here. And then rank we are finding out based on the marks. Highest mark is here 80, therefore I am giving rank 1, and 77 here, therefore I am giving rank 1. And then for maths we will give all the ranks. Second rank is 76, third rank is 75, fourth rank is 71, fifth rank is 64, sixth rank is 62, seventh rank is 61, eighth rank is 58, and the ninth rank is 56, and 10th rank is 45. Similarly for the science, we can see the first rank is 77, second rank is 70, third rank is 67, fourth rank is 66, fifth rank is 65, sixth rank is 63, seventh rank is 60, eighth rank is 59, ninth rank is 56, and 10th rank is 40. Now I am finding the difference between the ranks. 9 minus 4, 5, 3 minus 2, 1, 10 minus 2, 0, 4 minus 7, minus 3, you can put minus 3, 6 minus 5 is 1, 5 minus 9 is minus 4. You can put minus 4. Anyway, I am going to square it, therefore I did not put. 8 minus 8 is 0, 1 minus 1 is 0, 2 minus 3 is minus 1, 7 minus 6 is minus 1. Squaring it, you will get 5 squared 25, 1 squared 1, 0 squared 0, 3 squared 9, 1 squared 1, 4 squared 16, 0 squared 0, 0 squared 0 and 1 squared 1, 1 squared 1. I am going to substitute in the formula. Rs is equal to 1 minus 6 times sigma di squared divided by n into n squared minus 1. 1 minus 6 times 54. That is, you add all this, you will get 54 divided by 990. That is 10 squared minus 1 is 99 into 10, right? 990. That is 0.673. Therefore, strong correlation exists. We will see another example. Values of x and y are given here. Verify the correlation. The student nominal data is given here. Economics marks are given here. Statistics marks are given here. And then I am giving it in the column format, x marks, y marks. I am finding out the ranks for x because 85 is the highest mark, second highest is 75 and rank 2, and then third rank is 65, fourth rank is 60 and fifth rank is 55. Similarly for y also I am giving first rank 60, second rank is 55, third rank 50, fourth rank 49 and fifth rank is 48. Finding out the difference and squaring the difference, summation of the square is 2. Substituting in the formula, I get 0.9. Therefore, perfect association between x and y, economics and statistics. We will see another example. Values of x, y and z are given here. Verify the correlation. So, it is a beauty contest. 5 participants were there. 3 judges are there. Now, what is the monotonic relation? If one judge is giving a high rank, the other judge also should give a high rank. That is called monotonic relation. So, we will now verify this. So, I am going to give it in the column format 1, 2, 3, 4, 5, the nominal data, that is participant 1 to 5. The ranks given by the judges are here. X has given the rank 1 for the 1, 2 for 2, 3 for 3, 4 for 4 and 5 for 5. Y is given differently. He is giving first rank for the third participant. Similarly, Z judge giving first rank for the first, second rank is giving for the fourth participant. So, now we are going to find out the difference in the ranks between x and y. I call it as A and B, and difference between x and z, I am calling it as A and C, and difference between y and z, I call it as DBC, right? And then I am finding the square of this. So, we will see x and y, the difference is 1 minus 2 minus 1, and between 1 and z, x and z, 1 minus 1, 0, and between y and z, 2 minus 1, 1. So, I am finding out for all the contestants nominal data, and then I am finding out the square. So, RAB, I am getting 1 minus 6 into 14 divided by 5 into 5 squared minus 1, that is 0.3. Summation is 14, I am using it here. And for RAC between x and z, 0.9, good association. For RBC, that is between y and z, it is 0.5. Therefore, there is a good association. There is a moderate association between x and y. There is a good association between x and z and y and z. Right? So, Z is very cooperative with both x and y. Example 6. Values of x and y are given here. Verify the correlation. So, x 9 data are there. 3, 4, 5, 6, 7, 8, 9 data are there. Y 9 data are there. But if you see here, there is a tie. 35 is given obtained by 3 people, and 60 is obtained here by 2 people. Therefore, tie 1 is for 35, T1 is equal to 3 and T2 is equal to 2. 60 is coming 2 times. So, I am putting it in the column format. I am finding out the rank here. So, 45 is the highest rank 1, second highest is 42, rank 2. Similarly, I am giving for all of them. Similarly, for Y also I am giving the ranks, and you can see here I can give 1.5 and 1.5 here for, because 60 and 60, right? And then 1.5, 1.5 because I am going to give the rank 1 and 2. This is the highest mark. So, 1.5 is the average mark. Similarly, here 35 is coming 3 times, and where is 35 rank? What is the rank for 60 is 1, rank for 2 is 36, third rank also is given here. Third rank 40 here, and fourth rank is 35. So, 4, 5, 6 is the ranks I have to give for 35. So, I can't give 4, 5 and 6 because I do not know whom to give 4th rank, whom to give 5th rank. Therefore, average is 4th 5th, 6th. Average of the 3 rank is 4 plus 5 plus 6 by 3 is 15 by 3 is 5. Therefore, I am giving the rank 5 3 times. For 35, I am giving the 5. I am giving the 5. I am giving the 5 here. Right. So, this is how I am giving the ranks. And tie is T1 is 3 and T2 is 2. Why T1 is 3? 35 comes 3 times and T2 is 2 because 60 comes 2 times here. Right. Now the formula is 1 minus 6 times. So sigma di squared is 71.5 plus T1 cube minus T1 by 12 plus T2 cube minus T2 divided by 12 divided by n into n squared minus 1 because n is 9. Substituting the values and simplifying, you get 0.38. Therefore, there is a moderate relation between x and y. Is scatter plot essential before using the correlation test? Yes. Scatter plot gives you an indication, visualization, and you are validating with the parametric test. Option 1, yes is the correct answer. Select the correct statement. Option 1, Pearson correlation test gives the strength and direction of linear association between two ranked variables. Option 2, Spearman rank correlation test gives the strength and direction of monotonic association between two variables. Option 3, both the above. Option 4, none of the above. The correct answer is option 4, none of the above, because Pearson correlation is for variables and for ranked variables, Spearman rank correlation is used. Select the correct statement. Option 1, Spearman rank correlation test gives the strength and direction of monotonic association between two ranked variables. Option 2, Pearson correlation test gives the strength and direction of linear association between two variables. Option 3, both the above. Option 4, none of the above. The correct answer is option 3, both the above. Right. What is monotonic association between variables? Option 1, as one variable increases, the other variable never decreases. Option 2, as one variable increases, the other variable never increases. Option 3, both the above. Option 4, none of the above. The correct answer is option 3, both the above. That completes the hypothesis testing. Thank you very much for watching.